So we'll continue with this project. Now we'll do the hardware implementation of the FIR filter. I'm now opening the existing project that I've already created. As you see, the IP files are already added. So let's see how to add a custom component to create a hardware implementation. Now the QSys is loading. After the initialization, we will add our own component. So this is the existing QSys that I'm adding. You can see that all the components have been added, like the news processor, the on-chip memory, JTAG, and the performance counter. That is the filter custom component that I've added. So in order to add, you click on new component. You will see a window popping out. So this is when you have to add a component to the system. So I'll show how to create a component. So this is the FIR filter that I've created, and you add the RTL files, and then you select this as the top module, the interface that you've created that interacts with the filter, the bus, Avalon bus. So now after analyzing the files with no errors, you see the parameter declared separately shown where you can change it. And now you have to select this the protocol is selected automatically based on the naming conventions of your ports, and then you select the associated clock for the reset and associated reset for the Avalon memory. So save it, then you make the respective connections as before in the software. You will have to add extra connection to the filter and then assign base addresses. Once you add base address, you save the system and generate it. Make sure there are no errors pending, otherwise it will not go through. So once this is done, you will see that there are no errors. So after that, go to the quarters. There you edit the pin assignments as discussed earlier. Once the assignments are done and compilation is done, you will have to go to the programmer and add the files. So in order to add the file, I'm just waiting. So once the files are added, you program onto the board. As you can see, it is 100% successful. Save the program as CDF. Once that is done, now we'll go to the Neos 2 build Eclipse builder. The steps are as usual. Select the software folder or create a folder. Now the Neos 2 for Eclipse is open. As you can see, there are projects loaded already. The code now will have two inputs, IO write and IO read. So the IO write is to write the inputs and IO read is to read the output from the Neos 2. Now I am running this program onto my board and I'm waiting for the output from the hardware. It would take a little bit time. As you can see, the output is minus 34 as in the first case, and the cycles, if you notice, it takes less than what is